See, this the first question and second question. We have already done it in the class. Third is new, and the other fourth, fifth, they're completely based on the third one. So let us just discuss the third one. See, this says a metallic rod of length L is rotated with an angular speed omega, normal to the uniform magnetic field. You have to find the induced EMF, current, and heat dissipation if the resistance is given as R. See, when we talk about the EMF, we know motional EMF is given by BLV. So we also know one thing, V is equal to omega into R. So if I put the value of V as omega R, we get B omega R, and instead of DL, I'll use DR because a very small length is taken. So what I'll do, I'll integrate this B omega R DR to from 0 to the complete length of the rod. Now see, from here we can say B omega can be taken out common. R becomes R square divided by 2 from 0 to L. So that makes it B omega by 2 L square minus 0 square. So EMF will come out to be half B omega L square. This is an important formula that is used directly also. Okay. And see, if you have to calculate current, current is equal to EMF divided by the resistance. So which is equal to B omega L square divided by 2 R. Basically, we have taken this EMF divided by the resistance. Okay. And it said power dissipation also. See, power we already discussed the formula I square R. No, it said heat. Sorry, not the power. It said heat dissipation. So heat will be I square RT. So I square means squaring this term. So power, not the power. Heat, we can say this heat is equal to square this term. That means B square omega square L to the power 4 divided by 2R. So that makes it 4R square and into RT. So 1 RR will be cancelled. We can finally say heat is equal to B square omega square L to the power 4 divided by into T divided by 4R. So that is the formula which can be used. So rest of the questions are completely based on this. This one we've already done it in the class. Metallic rod frequency is given. This is also the same. Okay. So just note down this one, then we discuss the next assignment. Copy down it till here and just text me done once completed. Okay, Jobita, you are also done?
Yes, ma'am.
Okay. See, the last assignment was based on this induction, that was self or mutual. So, this question we have done it in the class, this also. The number of turns one also we have discussed. Okay, class C, the seventh question is completely new, which we haven't discussed. So let me discuss this. It says work done is given by half Li square. Okay. It says the work done formula is given by half Li square. You have to show that B square by 2 mu naught is the energy density. So we'll write the values of each. L is for a solenoid. Remember self-induction, we derived the formula and we got mu naught n square A into L. While for the current, see B is equal to mu naught Ni. So from here I can say I is equal to B divided by mu naught N. So I have the value of L, I have the value of L, half is there, work done can be calculated. Work done is equal to half. Now L is equal to mu naught n square A into L into I square. So that makes it B square divided by mu naught square into n square. See, n square will be cancelled. Mu naught will cancel 1 mu. Okay, so that leaves us with half B square by mu naught into AL. That is equal to work done. Now, what is this AL equal to? AL is nothing but the volume, right? We know volume is equal to area into the length. And we know one more thing, the energy density is also equal to the work done per unit volume. If I shift the term volume here, what will I get? Volume is down, so I just get half B square by mu naught. This is what we had, B square by 2 mu naught, B square by 2 mu naught. This also came once, that's why this is an important question. This one also we did it in the class in the form of derivation we have done. So we did for the coaxially coils present where we calculated the mutual induction. Write down this also and then we'll continue with the AC chapter which we were discussing. We started with it, we'll continue. You both understood the assignments. It would have been better if you would have submitted it from your end and then the discussion would have been there. Try to give the assignments now at least. Okay, Muniba, no problem. Once you get back to Riyadh, then just share it. Now, probably you would be going back soon because vacations are towards the end. No? Okay. See, we started with AC and we just talked about what is alternating current, what is a direct current, and we discussed about AC dynamo and we saw its construction. And finally, we saw E is equal to NB omega is the maximum value that is possible, and general formula for EMF is NBA omega sine omega t. Till here we stop. Now see, there are two derivations. Average value of AC for full cycle and average value of AC for a half cycle. Now, when I say average value of AC for a full cycle, when you calculate average value, full cycle means this. Remember, I told you that the coil turns. Like if you have the coil like this, it's starting from this point, then it will turn 180 degree, 90 degree, then again 90 degree, then again 90 degree, and back to its initial point where it started. That's what we discussed. The coil, if it is starting from this phase, 90 degree turn, 90 degree turn, 90 degree turn, and then back to the starting point. So in this full cycle, what's the average value of the alternating? That's what we are trying to get. Okay. So we already know current is equal to dq over dt. So from here, if I shift dt, I get dq is equal to integral of dt, and from 0 to t, 0 means the initial time. 0 means the initial time, while capital means the final time. Capital T means the final time. So we are talking about a one complete full cycle. So we integrate it from 0 to capital T. Now, see the equation of current, the way we have no E as E sine omega t. Remember one thing, class. This maximum value no, is represented through a symbol E naught. So we can say this is E naught sine omega t. This maximum value is NB omega. NB omega is the maximum value. This can be written as E max, or you can write it as E naught. So E naught is the peak value. Okay, this is the peak value. So that you can write, you can replace this as E naught. So that makes it E naught sine omega t. Similarly, you can write current as I naught sine omega t. This, let me just explain a little bit. Look, E is equal to NBA omega sine omega t. From here, this part is its maximum value. So this maximum value can be written as E naught. So E is equal to E naught sine omega t, because E naught is what? That's the maximum or the peak value of current. We say this is the peak value of current, E naught. Sorry, EMF, not current. Similarly, current is equal to I naught sine omega t, where I naught is a peak value. Peak means the maximum value that it can possess in this AC circuit. I naught is the maximum value, E naught is the maximum value that has been used here. I has been written as I naught sine omega t dt. Now here integration has to be performed. So when we integrate dq, it gives us q, which is equal to current is I naught, that is taken outside, sine omega t. See, when you integrate sine theta, you get, see, sine theta will lead to cos theta will lead to sine theta. But when we integrate sine theta, we get a negative cos theta. Okay. So this will make minus cos omega t. One point. Second point is the omega in case of integration gets divided. Okay. Minus cos omega t by omega whenever you integrate. If it was differentiation, this omega would have been multiplied. But the constant divides on integration. I'll write down this here. Constant term divides during integration. Okay, so minus cos omega t, from where? From 0 to capital T, we are integrating. All right. So Q is equal to I naught is there. Let's say minus I naught here. So if we put cos or omega also, let us keep it here, this omega. Let's put the upper limit first. See, when we integrate, we put the upper limit and then we will put the lower limit. In place of this small t, we will put the upper limit first. See, upper limit will be cos omega capital T first minus cos omega into 0. Okay. What we did, we just put the upper limit then the lower limit. Now what I'm doing, omega is equal to 2 pi divided by t. I'm using this relation, so at least I have 2 pi. I have the values. I cannot integrate omega. I cannot solve with omega. So if I do that, q is equal to minus I naught t by 2 pi. I have replaced this omega with 2 pi by t. So t goes up, minus I naught t by 2 pi. While what do I get here? Minus 2 pi by capital T into capital T minus cos 2 pi by capital T into 0. Wherever I used omega, I have replaced it with 2 pi by t. Now this t gets cancelled, okay? And 2 pi into 0 is anyway 0. So what do we get over here? Q is equal to, see, this is the value over a full cycle. We're not talking in terms of half cycle. So minus I naught t divided by 2 pi. Now cos 4 pi is 0. So 0 minus 0 is 0. Basically, the charge is coming to be 0. So value of current over a full cycle is 0. Because if charge is 0, current is 0. And if current is 0, the EMF's average value is 0. So current and EMF are 0 for what? For one complete full cycle. When the AC coil turns, for one complete full cycle, it is coming 0. That's the derivation for it. Step by step, have you all understood? Moniba, Jyobita?
Yes, ma'am.
Okay. Write it down, then we'll see the other derivation. Okay. Is it done now? Okay. And Shobita, you too?
Yes, ma'am.
Okay. See, the second derivation is that comes in the exam to write about the half cycle. What if this was the half cycle given? So for half cycle, the only change that will come is t by 2 will be there. Half of the time, half cycle means half of the time. Half cycle is like the coil starts from here, it goes like this, like this. That's it. It doesn't go like this and completes. Okay, it's like if you have the coil, it starts from this, it will turn, that's it. Okay, it won't take a complete rotation. So t by 2 will be the time. So just the change will come in the time, that is t by 2 will come. Okay, so if I have t by 2 over here, now 2 will also be cancelled. So this is not cos 4 pi, which is 0. This time this is cos pi. What is cos 180-degree class? Cos 180-degree? Yes, class, what is cos 180-degree? You people don't know what is cos 180-degree?
-1.
-1, yes, -1. Okay. So see, this makes cos 0-degree 1. This is cos pi, that is 180-degree, which is -1, minus, and cos 0 is already 1. So -1, -1. So see, there would be a change from here. This won't be there. This will be equal to minus I naught t by 2 pi into -2. Minus will be cancelled, 2 will be cancelled. So charge is equal to I naught t by pi. Now this is the charge. What will be the current? Current will be the charge divided by the time. Time is t by 2. 2 goes up, so 2 q by t. That is 2 I naught t by pi. Okay. Charge divided by time, and this time is also there. No, so time will be cancelled. Formula of I average will be equal to 2 I naught by pi, 2 by pi I naught. This is the value of the average current. Similarly, the average EMF will be equal to 2 E naught divided by pi. That's it. So this is very important to write the whole formula for the peak value. I naught and E naught, they are the peak value. Now we'll talk about an RMS value also. So remember, I naught and E naught, when we talk, these are the peak values. Peak values means maximum values. So this derivation just has one small change. What was there? T by 2 was there. So instead of 0, this is -2. So you're getting a value I naught T by pi. Charge is I naught T by pi. Time is T by 2. When you take the ratio, you are left with 2 I naught by pi. Yes, Jobita Muniba, is it clear to both of you?
Yes, ma'am.
Oh, complete this. One more derivation is there, but a different derivation that we'll see. Don't write this part again. Just write down from here. Okay, and time is t by 2 is the half time.
Ma'am, I have a doubt.
Yes, Muniba.
How is cos 2 pi by t into 0 minus 1?
This one, Muniba, you're asking cos 2 pi by t into t by 2?
No, cos 2 pi by t into 0 minus 1.
Because this is cos 0 degree, no? So cos 0 degree is equal to 1.
Okay.
Okay, I get it, Muniba, why you got confused. In the previous part, when we did the full cycle, I think I wrote it as 0. Yes, just check in the notes class.
Yes, ma'am.
Yeah, okay, just make a correction. I think by mistake that was it. Now I'm recalling while writing. See, cos 2 pi minus cos 0 degree was left. I thought it was 4 pi, that's why I wrote it. Cos 2 pi is 1, cos 0 degree is also 1. So 1 minus 1 was equal to 0. That's why when you multiply, charge was 0 and current was 0. Okay, just write this, Jovita and Muniba, in the previous part. I think by mistake I've written this as 0 minus 0. I wanted to write 1 minus 1 as 0. Okay.
Yes, ma'am.
All right. Jobita, you too have done?
Yes, ma'am.
Okay. One more derivation is there because one more kind of current is there. See, these are derivations, but they'll be used as direct formula also. Okay. Now, RMS current is used, effective current term is given, virtual current is given. See, basically, we are just continuing with what we left in the last class. Formula, this is a derivation which comes in the exam. Now, what is meant by the term RMS? RMS current. See, R stands for root M stands for mean, while S stands for square. Okay, so these steps are as followed. You don't see the formula, the name says RMS current, root mean square, but you first square the term, then you take their mean, and finally you calculate the root. That's how you have to remember the derivation, and you will be able to write down the entire derivation. After the derivation, you need to remember the formula also, so that I'll discuss with you. So see, if I say squaring the current, means I will say I will square I naught square sine square omega t. First step I have done, I have squared the current. Second says mean value. Mean value means this has to be integrated from 0 to t divided by the integration of dt from 0 to t. That's how we take the mean value. The quantity divided by the time, but everything is getting integrated. So I'll have to put integration in both the terms. And finally, it says root. So a root sine all over IRMS is equal to this. We have to derive this. We have to simplify this further. But tell me one thing. Is this step clear, or you want me to repeat any point? Clear?
Yes, ma'am.
Okay. All right. So see, what we do, instead of solving this whole huge term continuously, what we do, if we just solve this part first, this one, then we can later put it, divide the integral of dt from 0 to t is what? It's just capital T only. See, that will be capital T from 0 to t, which is t minus 0 equal to t. This denominator is t only. So we'll just add the input in under root and divide it by t. So let's solve this, because solving this whole square root with the square root will be a little difficult. So we are just solving this integral of I naught square omega t dt from 0 to t. Yeah, dt comes whenever you integrate a quantity, right? So see, here IRMS is equal to I naught square will be taken out common, sine square omega t. Okay, I naught square sine square omega t. See, this is written as I've written, I think here. Sine square omega t is written as 1 minus cos 2 omega t divided by 2. This is there, integrating it from 0 to capital T. This is an identity that I have used. Sine square omega t is used as 1 minus cos 2 omega t. Now, when I integrate it, see, when I'll integrate it, dt will also be there. So dt will be multiplied. And when you integrate dt, you get small t. When you integrate dt, you will get t. And when you integrate cos theta, you get sine theta. And what did I tell you? The constant term divides. So here the constant is omega, it will be divided here. So what do we get? See, this 2 is taken out here. 2 is taken out here. I'll just explain you here. Look, I naught square by 2, I naught square by 2 is taken out. Now, what is left? It's like integral of dt from 0 to capital T minus integral of cos 2 omega t over 0 from 0 to capital T. This is cos 2 omega dt. Okay. See, if you multiply dt with them, this is how integration will look like to you. So what did we do? When you integrate dt from 0 to t, basically t is there without putting the limits. And when you integrate cos 2 omega t, in fact 2 I will not write. I have taken 2 already out. So I am not writing this 2. This 2 I have already taken. So I'll be left with cos 2 omega dt. Look, I naught square 1 minus cos 2 omega dt by 2. Dt getting multiplied to 1 gives dt. Integral of dt gives small t. I naught square by 2, I naught square by 2 I have written. Cos 2 omega t. Cos becomes sine 2 omega t. And we take the constant term in the denominator. So this gets divided by 2 omega. That's why I have this. Tell me, till here, till this step, is it clear?
Yes, ma'am.
Muniba?
Ma'am, you only took 2 common out, right? So why were you writing 2 omega?
2 omega is because of this one. Like when we had omega, we divided it by omega. When if this is the constant term which is coming, if this was 4 omega, we would have written divided by 4 omega over here. Got it? This is not the one, the 2. 2 has been already taken common. Okay?
Alright.
All right. So see further when we put up the value, see, we get I naught square by 2 is there. Now capital T minus 0 would be there. From here, capital T minus 0. Now we are putting the limits. And this is capital T minus 0 minus. What is this? Sine 2 omega. Now let's write the value of omega as 2 pi by t. So 2 pi by t into t divided by 2 in, let's write this as 2 omega only. Let's write this as 2 omega. Sine 2, this omega I have written as 2 pi by t. And the value, like we did in average value, I have put the upper limit as t. Got it? What did we do? We've just put in the limits. See, sine 0 will eventually be 0. When I write no sine the whole thing into 0, it will be 0. So see, now I think it will be a little clear. This step was it, t minus 0, t minus 0. And omega's value here, this I have left. Now is this step clear?
Yes, ma'am.
Okay. See, from here, t minus 2 omega is written together. What is left from this? This is already 0. Sine 2 pi divided by t into t. See, tt will be cancelled, right? When we write it from here, this tt will be cancelled from here. T minus 2 omega has been taken out. Okay, they have been written together. Because see, when you open up the bracket, this is not multiplication, they are basically getting subtracted. So this 2 pi by t is left, this t will be cancelled. When you put, see, 2 pi by t into capital T. This is from 0 to t, so we have just put this value, right? T, 2 pi by t, and this 2 is, okay, I forgot to write 1, 2, just wait. It said sine, so sine 2 into omega 2 pi by t into t, so capital T. So that leaves me with 4 pi by capital T into t from 0 to t. In fact, just sine 4 pi by t. Right here, if I put the value, or if I just leave it till here, let's say into small t only. We'll put the values later so that you don't get confused. Now see, what did we do? This t minus 0 is there. T minus 1 by 2 omega is written separately. From here, sine 2, 2 omega. Omega is written as 2 pi by t into small t. I have written. This step is clear? Yeah, Muniba, Jyobita?
Ma'am, can you explain again?
Yes, ma'am.
Okay, I'll explain this. Look, till this step we have got it. I am not putting the limits right now, or I am just putting the limits from t minus 0. See, what did we do here was basically I naught square by 2. So I naught square by 2 we have written. Capital T from the limits we have put. Okay, you can put it as small t also, but capital T we have put. Because we just put its limit. The limits of sine part is still left. We'll put it later. We'll put it in the next step so that at least it is clear. Now, t and the I naught square by 2 is done. T's limits also have been put. Okay, till here. 2 omega is there. 2 omega I have written. All right. Now, in fact, leave the sine 0 also because we are not putting the limit. We'll put the limit in the next step. This from 0 to capital T. We have just put the limits of capital T. This we'll put it in the next step so it's a little clearly visible. Look at this, t minus 0, t minus 0. I naught square by 2, I naught square by 2. This is sine, so sine I have written. It says 2 omega. So 2 into this is omega. Look, 2, this whole term is what? Omega into t. 2 omega t, 2 omega t. Divided by 2 omega, divided by 2 omega. It's just that its limit I have put. These limits are left. Now got it, Muniba?
Yes, ma'am.
Okay. So see, this makes it 4 pi by t. So 4 pi by t I have written. I naught square by 2, I naught square by 2. T is there, T is there. Minus 1 by 2 omega, minus 1 by 2 omega. Sine 4 pi by t into t from 0 to t. The same step with just a little rearrangement. Okay. Now we put in the limits for sine. Capital T here, then 0 here. See, sine 4 pi is also 0 and sine 0 is already 0. So this whole term of sine will be 0. Minus 1 by 2 omega was with this only. If I write, I'll just write it a little clear. This was 1 by 2 omega and capital T minus. This is what we had. Capital T and capital T will be cancelled. When you put the upper limit is capital T, lower limit is 0. So capital T will be cancelled. Sine 4 pi is 0 and 4 pi into 0 is already 0. Sine 0 is 0. So this whole term will be 0. Is that clear?
Yes, ma'am.
No. So you are just left with I naught square by 2 into capital T. So that was the whole term. We were just solving this inner term, no? This part. So its value, when you derive the whole thing, will come out to be I naught square T by 2. Now for the IRMS, what did we discuss? I naught square T divided by 2. Then you multiply it with time also. You divide it by time. This integral of dt, which is equal to t. So this t will come here. Okay. The square part has been solved. Integration mean has been taken and a root is put. T gets cancelled. That is I naught square by 2 under root. So what do we get? We get I RMS is equal to I naught divided by root 2. And what was I naught? I naught was the peak value of current. With this, we have already discussed it. This is the peak value of current. While IRMS is the RMS value of current. Similarly, same derivation you can perform and you will get the value of ERMS, which is equal to E naught divided by root 2. This is the peak value of EMF. Peak value of EMF. While this is the RMS value of EMF. Is the derivation clear now?
Yes, ma'am.
Jobita, what about you?
Yes, ma'am.
Okay. If there's any confusion at any step, class, please ask. Okay. Write it. This covers a major topic. Now we have to just do individual circuits and then LCR. Please write it, class. Yes, girls, done? Okay, then let's practice the question. Muniba, you've also completed?
Yes, ma'am.
All right. So, class, this relation is very, very, very important from numericals perspective. Okay. The derivations are also there, but derivations, derivations can come, cannot come, but the relation will be used further also. Now, there's a question. This says E is equal to 140 sine 300t. Now, this is the equation given. I'm writing it again. E is equal to 140 sine 300t. Now, if I write the original equation was E is equal to E naught sine omega t. Now, it says peak value of the voltage. See, from here, we know what's the peak value of voltage. So, in this equation, which quantity is replacing? Can you tell? Peak value of voltage. From here, see, this is representing this. So, this manner. E naught is equal to
140.
140. Okay, so very easy. 140. E naught is representing this. Sine has been written. Omega is representing this time. Same equation, it's just the analogous part is written. So when it says what's the peak value of the voltage, straight away the answer to the first part will be peak value E naught is equal to 140 volt. But put the units, Muniba. Okay, when you write the peak value. Second part says it's RMS value. We just studied a relation that E RMS is equal to E naught divided by root 2. So it will be 140 divided by root 2 volt. That is its ERMS value. It says frequency of the supply. See, angular frequency is there. See, it is 300. So if this is 300, there's a relationship between angular frequency and linear frequency, that is 2 pi, where omega is the angular frequency and nu is the linear frequency. We have done this relation multiple times by now, so you should remember. So linear frequency will be omega divided by 2 pi, which is equal to 300 divided by 2 pi. So frequency we can say 150 by pi hertz. So that's the answer. Formula based question, you'll be able to answer. Okay, write it. That completes with this whole topic. Then we'll see what are phasor diagrams. Those are relatively easier than this. Please write this first.
Ma'am, do we have to put the value of root 2 or let it be like that?
What?
Do we have to put the value of root 2?
See, for the value of root 2, you can put 1 by root 2 is 0.607, 0.707. Okay. So you can remember this as, just wait, I'll just tell you. Because this also, to few things you should remember. Value of, yes, this is equal to 0.606. See, when we had no I average or E average was equal to 2 I naught by pi or 2 E naught by pi. This also should be remembered by you. This is 0.636. Around 0.62 we take. This would be equal to 0.636. Yeah, 0.637. You can round it off. So 0.637 I naught or 0.637 E naught. So this, if you remember this data, your calculations will be easier. Now, similarly for I RMS or E RMS, this is I naught divided by root 2 or E naught divided by root 2. When I'm putting the slash, I hope you're getting whichever is asked. Okay, this is 0.707 I naught or 0.707 E naught. So this, remember this, calculations will be better. Okay?
Yes.
Yes.
Ma'am, it's E naught by root 2, right?
Yes, yes. Here also it is root 2.
Ma'am, please scroll down. Done.
Okay, look, when we talk about phasors, phasors are basically the rotating vectors. Now, sometimes it is very difficult to represent current and voltage because they are varying. They are continuously varying. This is not your direct current, that current is also fixed, voltage is also fixed. So current is variable, voltage is variable. So we consider as if these were vectors, vector, not the vectors that we have studied. Rotating vectors, the changing vectors, they are represented through phasors. So we draw a diagram where we show the position of the voltage and current and we represent what's the angle between them, so that we'll get an idea, is the voltage greater or the current, like this. See, this is how we take like a basic graph. If you just have to explain to a layman that current is exceeding the voltage, let's say this is the current, this is the voltage, EMF, and let's say the angle between them is phi. So see, phi tells us what? Phi tells us what's the gap between current and EMF. So this gap is known as the phase angle. This will, if I plot it, if I draw it 90-degree, everything can be just understood. Like a rough picture would be given. So they are just rotating vectors. See, voltage is a scalar, current is a scalar. So they're not literal vectors that we study. Rotating vectors means rotating terms that are there, because you cannot just solve. They are phasors. Phasors have a different method of solving. You cannot just add or subtract. And let's say they make certain angle omega t from the base axis also. Whatever current makes or EMF makes. We write now sine omega t, cos omega t at the end, I naught sine omega t. So that omega t will also be depicted and their angle will also be given. This is known as the phasor diagram. So I'll read it with you. This says a rotating vector that represents a sinusoidally varying quantity. We know the sinusoidally varying quantity is the alternating current. So what are phasor diagrams? A diagram that represents alternating current and voltage. The current and voltage of the same frequency as rotating vectors. Okay, as if they are rotating vectors, which are known as phasors. The best word is use the term phasors. Along with a proper phase angle between them, means this phase angle which is occurring between the current. See, if the current is, let's say, flowing and EMF flows like this, so there is an angular difference between them. That is termed as the phase angle. So we have individual circuits to deal with. Circuit only having resistor, circuit having only an inductor, circuit having only a capacitor. These three circuits we have to deal with. But before that, write down this part.
Done.
All right, if it's completed, then I'll stop here because the next topic we won't be able to complete. This requires one class. So on Wednesday, I'll complete all the 3 circuits and we'll move on to the LCR circuit. So please revise this part because that's a fresh topic. So you can just do it. And Muniba, I understand you're traveling, but once you are back, please cover your pending assignments. Okay. And Jovita, your assignments are still pending. Please share them.